Today we're going to be looking at a second type of transformation called a reflection. The mirror image produced by flipping a figure over a line is called a reflection. The line is called the line of reflection. To reflect a shape over the x-axis, change the sign of the y in the coordinate. To reflect a shape over the y-axis, change the sign of the x in the coordinate. So when you do a reflection, what you're going to get is the mirror image of the shape that you're reflecting over the given axis. So we're going to try just rewriting the coordinates to begin with. So triangle ABC with vertices A, 4, -5, B, 1, -2, and C, 5, -1 is reflected over the y-axis. Where are the vertices of the new triangle located? So remember, if it's reflected over the y, we change the sign of the x. So in this case, this is the x, this is the y. So we have A prime. Remember, after a transformation, the new shape has prime signs. So A prime, if we reflect it over the over the y-axis, is going to change the x to -4, and then the -5 stays the same. So it only affects the x of the coordinate because we're reflecting over the y. B is going to be B prime, changing only the x, -1, -2. And C is going to be C prime. Again, reflecting over the y-axis affects only the x, so we have -5, -1. Similarly, in number 2, quadrilateral DEFG with vertices D, -2, -5, E, -4, -5, F, -6, -1, and G, -3, -1 is reflected over the x-axis. Where are the vertices of the new triangle located? And that should not say triangle. It's a quadrilateral. That is a mistake there. But we can go ahead and apply the rule. Now we're reflecting over the x-axis, so only the sign of the y is going to be affected. We have D prime, and that's going to be x staying the same, -2, but the y becoming the opposite sign, so +5. E is going to become E prime. The x stays the same, -4, but the y is going to become positive because it's negative to begin with. F, again, is going to become F prime. The x stays the same because we're reflecting over the x-axis, and the y becomes the opposite, so it's -6, +1. And then lastly, G is going to become G prime. The x stays the same, and the sign of the y changes. So those would be our new coordinates of the reflected quadrilateral. So something important to see, some of you guys, when you start to graph this, are going to be able to do it without having to physically write down the coordinates, but it's important to be able to recognize what coordinates are reflected when you just see the coordinates written out itself. So for number 3, graph T, -6, 1, R, -5, 5, A, -2, 5, and P, -1, 1. So we go ahead and neatly graph those points on the coordinate plane. -6, -1. Whoa, excuse me. Try again, Mrs. Kiesler. All right, -6. And then +1 would be here. And again, remember that it's really important to label those points. Then -5 and +5. Then -2 and +5. And then -1 and +1. Trap for trapezoid. How clever. Again, you should be using a straight edge to graph your points. Do it very neatly. Your graph should look much neater than mine. And it says to start by reflecting trap over the x-axis. Now, remember, this is the x-axis. So our image is going to be flipped over that line, upside down. producing the mirror image of the trap you now see. So we can physically change the coordinates if you need to see it so that it's more obvious how to graph them. So our t, because we're reflecting over the x-axis, is going to become -6, -1. Remember, reflecting over the x-axis only affects the y. Then r, remember it's also prime. R prime is going to become -5, -5. A prime is going to become -2, -5. And it's asking for p prime, so p prime is going to become -1, -1. We can go ahead and graph those points. So again, t is -6, -1. Label it t prime. R is -5, -5. Why is it doing that? 1, 2, 3, 4, 5. A is -2, -5. A prime. And P is -1, -1. P prime. And neatly draw your lines to create your shape. And you can see that trap has been reflected to get trap prime, creating a congruent shape. These two shapes are exactly the same, therefore they are congruent. They're just not facing the same direction. So R is 5 units above the x-axis, where R prime is 5 units below the x-axis. T is 1 unit above the x-axis, where T prime is 1 unit below the x-axis, creating a shape that's been reflected over the x-axis. So now it says reflect trap prime over the y-axis. So now we're reflecting a prime shape. So our reflected shape is going to have double prime to show that it's a second transformation. So our t double prime is now being reflected over the y-axis, so we have to affect the sign of the x in t prime. So now that x is going to be, instead of -6, it's going to be +6, -1. Then r double prime is going to affect the x in r prime, so it's going to be 5, -5. Then a double prime is affecting the x in our a prime, so it's going to be 2, -5. And p, which it's asking for, p double prime, is going to be +1, -1. So now we can go ahead and do that transformation. T double prime is being reflected from this t, so it's basically flipping over this line. Right now it's 6 away from this y at the y-axis here. So it's going to be 6 away in the opposite direction right here, labeled t double prime, which is the coordinate we came up with. Then our r is over here, 5 units away from the y-axis. So r double prime is going to be 5 units away from the y-axis in the opposite direction, labeled r double prime. A is here, so now it's going to be, as it is 2 units away from the y-axis, we're going to go 2 units away from the y-axis on the opposite side. And then our P is 1 unit away from the y-axis, so we're going to go 1 unit away from the y-axis on the opposite side. And you can see, again, if you're drawing it neatly using your straight edge, that we again have reflected trap just over another line, creating another congruent trapezoid on the coordinate plane. All 3 of these trapezoids are congruent. They're exactly the same size and shape, just in a different position on the coordinate plane. So you're going to go ahead and do the rest of the lesson on your own. we'll be around to help you out.